I'm the co-founder of Kane. We're an AI consultancy firm that provides data science and machine learning services to different corporations. We also provide training as well as helping other companies build AI roadmaps. For my session, I'll try to talk about what is AI and how AI can benefit different companies. We'll go through case studies that we went through before with multinational companies. Finally, we'll talk about how to create an AI roadmap for your organization. Thank you.
Hi everyone, I'm Kane. Today I'm talking about data science case studies and formulation of AI roadmap. So a little about myself. I'm from Finco, a Hong Kong-based AI and data science consultancy firm. So we do general AI consulting. So we do like NLP, computer vision, and predictive analytics. Work with a lot of different corporations in different industries before. We also create a product doing social media listening using AI. I'll talk a little bit about our product as well. So just a little bit about myself. I'm a co-founder of Finco and Lens AI. I also teach at Hong Kong U Space as an honorary course coordinator and also as a lecturer on big data and machine learning. I'm also a chairman of Hong Kong Data Science Society. So the talk today would basically focus on more about data science case studies. I will talk a little bit about what my company did for a lot of the corporations in Hong Kong. And also some generic case studies that you guys could find online, just to showcase what big data could do. So for this talk, it would not be that technical. So it would just be more generic and more business-like, and also would be kind of for anyone from a beginner to an advanced person. Feel free to listen in. So a little bit about what I'm going to talk about is just AI in general. The case studies we have done, and also because like a lot of clients that we have now, especially in Hong Kong, are trying to create an AI roadmap, trying to figure out how to really find business value from what they do. So that's why we have created some kind of exercises and also kind of a framework on how to create such AI roadmap. I'll also go through that as well. So this is just very generic. What is AI? What is data science? So AI is the ability of a digital computer or a computer-controlled robot to perform tasks commonly associated with intelligent beings. And then what a data science wants to do is to use AI to help businesses to create business value using these AIs and these machines. Most of the time, when we talk about AI, we're talking about machine learning and deep learning. How we could use machine learning, which requires data to come in and for the computer to automatically analyze the data, to automatically find patterns, to find business value for a customer. So this might sound a little vague, and that's why I'm going to go through some different AI case studies to talk about what AI could do and what our company helped other corporations and some government agencies to do in Hong Kong. Usually we put the use cases into 3 categories. There are also some other minor categories, but we like to fit it in these 3 because we think that these are more prevalent out there. One is computer vision, how computers can understand images and videos. Second, natural language processing, how computers could understand and write and talk human languages. And finally, predictive analytics. Sometimes we put recommendation engine in predictive analytics as well. But then mainly it's mostly about propensity modeling, trying to predict what people would do and whether we could, and it's used mainly in targeted marketing or maybe in demand forecasting, things like that. So again, I'm going to go through some of the use cases that my company has done, but then some of the use cases are just use cases online that we think would share how these AI use cases go. So first, computer vision. So this use case that I want to talk about is this government agency that we work with that has a lot of really old maps that has really important vital information about that area. The problem is that a lot of times when you do AI, the data that they give you is not clean. For example, the maps might be very dirty, or the maps might not be scanned correctly. And basically, they would have drawings on the maps where they say those are important areas, and we have to use a lot of computer vision techniques to extract those polygons. And also there will be things like legends, grid lines, whether we could use computer visions to understand them. And also with the polygons, there's a lot of different patterns. So we have to train the AI using machine learning and other techniques to figure out what those patterns are and to try to find those polygons and then create coordinates that can map to the real world. So again, some of the challenges that we came through, which happens a lot in AI machine learning use cases, which we a lot of times we think that machine learning is the most important part, but before that, there's also the data processing that you have to do, and for computer vision, you might have problems like the old maps are drawn by hand, they're faded colors, hard to identify handwritten figures, information overflow, overlap of words, and the result precision. So things like that are things we have to keep in mind and try to fix before we actually go on with the project. Some other use cases, because we're in Hong Kong, so we're really close to China, and in China, computer vision is quite prevalent. They are able to capture a lot of criminal suspects using facial recognition camera set up by local police. And in 2017 Cultural Fair in Shenzhen, they're able to capture 25 criminal suspects. So my company didn't do this at all. These are just cases online and during newspaper. But then we also know that in Hong Kong, some companies, some fast food restaurants are using computer vision for other use cases. For example, they might try to see how clean the restaurant is by putting cameras up there and seeing how long it takes for restaurant workers, waiters, and waitresses to clean up different places. And also, like at some fast food restaurant, people really like to borrow the bathroom and never really use it. I never really use the premise or buy food. So they're also able to use computer vision to do that. Just some tips about computer vision. A lot of times it's actually about the data that you have. A lot of things, if we use APIs like Google's and things like that, you could cater to regular objects, everyday objects. But when we're doing analysis on videos, some certain actions, like we work with a big retail store where they're trying to track how people grab things from shelves, that you really need a lot of labeling. And then we hired a team for this retailer to actually label those data so they could track the hand movements of grabbing certain items or talking to certain personnel. Identifying the personnel itself is also kind of something that we have to label data for, because Google APIs and things like that wouldn't have such data. And there are also some open source some open source tools that allow data labeling a lot easier. For example, in videos, you could just track and say from one frame to another frame, and it will automatically help you track the person. So you could say that is a waiter or that is a retail staff. Another example that you guys might probably know is that Amazon Go, this retail store where people could walk in and out without lines. They use a lot of things like computer vision. Plus, they also use sensors to try to understand when people grab an item. Sometimes just computer vision itself might not be good enough. Sensors also help, because let's say the camera is blocked, then you're unable to really see that people took away the item. So let's go on to NLP, natural language processing. So again, as I mentioned, it's how computers understand, interpret, and manipulate human language. A most common use case is chatbot. But then for my company, we work on, other than chatbots, we also work on other use cases for the NLP. An example is that we work with Lenovo. We create a multi-intent classification to facilitate AI-based social media engagement. So what happened was that beforehand, Lenovo, global Lenovo, had a team where they read social media every day in different languages, so that they could create a report to send to the different management about how different products, like for example, a Motorola G4 or a Motorola Z3, how is that phone doing? And there's a lot of different issues that they want to figure out. Like for example, here are some product-related issues, like battery issues, display issues. And then there's also service related, like if there is no response from people, is it like taking a long time to repair? Is a warranty problem? And then so manually have a team that read the social media to generate this report. And it's quite time consuming and also quite costly to hire a lot of people, especially with different languages. So what we did is that we, using NLP and AI, we automatically understand what they're trying to say and to create and to classify an intent that's saying, oh, from this message, what are they trying to say? So this automatically classifies all the social media that they have from Twitter, from Amazon, from Facebook, so that they could quickly generate reports and to find for each product, each build, what kind of problems there are. Because for each product, even like with different builds, there might be different battery issues, speaker issues, and display issues. And also from this, they can automatically figure out what kind of service-related problems they have. And they no longer need to hire a team to automatically read through each social media message to build reports. For the product we did, we also allow them to create new models. So if there's a new intent or tag that they want to do, they could automatically feed around like 100 different messages. And the computer would start understanding, using machine learning, understanding what this tag is about, and send them related tags of such messages. Again, so what I want to say here is that we create a platform to do that. And also now, I mentioned that we have a product earlier. So we have created this product as focused on Chinese NLP, mainly Cantonese NLP, because we're from Hong Kong, where we basically, one is that we scrape all the data from different places um, like Hong Kong websites, Facebook, and things like that, to analyze social media trends on there and to try to predict what kind of future trends there are. So different companies that work with us might be including fashion brands or Hong Kong local brands who care really a lot about social media. For the fashion brands, they try to figure out, oh, what are the upcoming trends that they want to know, as well as what kind of KOL that they should hire. So because we have scraped all the data from Facebook, we're able to see what kind of KOL really do have an impact doing certain things. Another thing is that with this product, what we do is that because we scrape all the news from everywhere, we are able to, so we create bots to grab data from news and articles. If there's any, and also forums, if there's any negative news or negative threads about people, we're able to see that and send it by WhatsApp to that company's management so that they are able to see what's wrong with the company, and if there's any PR things they might have to do early. So yeah, here again, we retrieve sufficient data for social monitoring purposes, and we also extract insights from social media sources with scientific precision. And then there are also chatbots. This is a chatbot that I found that try to be your friend. Chatbots are a big use case of AI because they're able to help you with a lot of service stuff, and also especially like for example when we're working with Lenovo, we also help them to consult them on the chatbot, so that when people have any questions, instead of finding a person to talk to them, Lenovo could save costs by using chatbots. Here's another case study that got talked about a lot. It's called Google Duplex. I'm sure a lot of you guys probably heard of this, but for those who don't, Google created this around 2 years ago that allows you to type something to this Google Duplex, and they will automatically call, this robot will automatically call people to schedule appointments. So usually we do a lot of these workshops, and we usually ask these questions to people. It's like, how do we apply this thing to a company? And then whenever we do this, we also have to keep in mind our difficulties implementing such system, and have our clients to tell us that as well. Because with AI and machine learning, it sounds good on paper, but if we couldn't implement it, that's also a problem. And then finally, the next category I want to talk about is predictive analytics. I'm going to start with a use case that maybe a lot of you guys know, and then we'll talk a little bit about the predictive analytics things I've been doing in Hong Kong for different companies. So again, this is a pretty popular use case about Target. So basically, Target was using big data to analyze whether people are pregnant. The reason why is that because people's habits are really hard to change. And because people's habits are really hard to change, the only time when they change is when there's a big life event. For example, someone get married, or they're moving to a different country, or or they have a baby. And so what Target wanted to do was to figure out who is pregnant so that they could do targeted marketing to those people and send them coupons to those moms. Because once you converted them into people who buy a lot of stuff from you, the customer lifetime value would go up. In Hong Kong, we have a lot of use cases like that. It's one of the for machine learning and AI. This is most obvious in translating AI into sales, which translate to money. So a lot of people in Hong Kong are quite interested in that. So again, how they find this pregnancy index to see how whether someone is pregnant is that they throw in a lot of data over there. Demographic information, age, whether they're married, have kids, what part of town they live in, how long it takes for them to drive to their stores, salary, credit cards, ethnicity, whether they're divorced, what uh, your house, where you went to college. But then most importantly is transactions. So like from previous transactions they have at Target, whether uh, to try to predict whether the person is pregnant or not. So and then with machine learning and AI, they were able to figure out some insights. So after they created this pregnancy index, they find that it does work. That when people do certain transactions, it shows that certain things. For example, if they buy a lot of soap and cotton balls, that is a sign of pregnancy. If they buy larger in quantities of unscented lotion, that's the beginning of second trimester. If they buy a lot of supplements such as calcium, magnesium, and zinc, they are on the first 20 weeks. So what I'm trying to bring out here is that with AI and machine learning, the model doesn't have to be black box. Sometimes it does when you're using deep learning, but at other times you could find insights from these machine learning models that you could tell back to the business so that they know how to target people. A lot of times, like for example, this other client that I have, we are building machine learning models, but it has to be interpretable because the data that they have only shows a very small sample size of the clients, and then we have to find, oh, other than these people, how could we link our insights into the rest of the population? Uh, so so for the Target case, what happened was that one day a dad called Target and said, "My daughter got this in the mail." The father said, "She's still in high school, and you're sending her coupons for baby clothes and cribs. Are you trying to encourage her to get pregnant?" So here, what happened was that the dad uh, was really mad that, oh, through this AI and data science machines, somehow they're sending all these coupons to her teenage daughter. So the Target management was quite kind of disappointed at this, and then in a month they tried to call back to the dad and say, "Hey, hope you're okay. Sorry about that." But then what actually happened is that the father said that there was something that he didn't know when he called them at the time. So it turns out the daughter is pregnant. So what I'm trying to bring out here is that that it was so powerful that with big data, with all the transactions, that uh, the pregnancy prediction was so powerful that it's able to know something that even the father who lives with the daughter didn't know. And also there was another lesson from this is that from then on, Target was really careful about how they do the promotions, even if they predicted that, oh, hey, this person might be my target audience, that this person might be pregnant, they wouldn't only send them pregnant stuff. Instead, for the pamphlet or the coupons they send them, there'll be some other random coupons, such as, let's say, orange juice, basketball hoops, and things like that. The reason for that is that because people really care about the privacy and they think they're being targeted, that might actually be bad for them as well. Because they feel that the company is infringing on their privacy and it's kind of scary. So they might give more coupons for baby clothes and stuff. So the person feel like, oh, I'm not targeted, but then these are very useful coupons. and then they hope to go to target so that they would find people with a very high customer lifetime value. So in general, in Hong Kong, we do a lot of this. Basically, this is a very common use case of data science and AI. So we look at customer behavior. For example, we were working with this very big company that has a lot of transactions with a lot of Hong Kong people. And then we basically use AI machine learning and supervised learning to try to put those people into different customer segments. So based on the transactions in a lot of different stores, we try to segment them into different people. And then we use AI machine learning to match the best product deals coupons to those customer segments to encourage them to do certain actions. For this part, it depends on what the company wants. For example, some would say, hey, I want them to go up in loyalty. So like, for example, I want them instead to be in the silver member, I want them to be gold member. Or maybe I want them to do a certain thing. For example, I want them to top up more money in my credit card or in my debit card or something like that, or boost up the credit limit. It depends on what they do. But then, so basically we identify different customer segment and then we send them different product and deals so that we could boost sales and increase profit. And then we also work with another retailer where we're doing the similar thing, where we use all the data to try to predict for different segments how to increase their customer lifetime value. And then basically, a lot of times in retailers, it's about whether I match my competitor, matching competitors' discounts on certain products. But then which products should match or not match really depends on whether the customer segment is a high customer lifetime value segment. And that we could use AI machine learning to do. And also for assortment planning, which means what do I put on a different assortment at the different stores, which segment I should put those items on. And also for the items itself, how do I make sure that people could buy everything that they want? This we could use decision trees and also from previous transactions, basket analysis to see how people buy certain things they want and what is compatible. For example, there are things like shampoo and conditioner might be compatible. But then let's say for shampoo, there are different types of shampoo, right? There will be shampoos where they are very similar, that people use them as substitute, or there will be shampoo where people want to try different shampoos at the same time. I guess beer might be a better example. There are certain beers that are substitute of each other. They might all still be cheap beer. But then, for example, let's say craft beer or IPA beer might be different from regular beer. That people might say, hey, I want to buy this regular beer, but I also want to buy IPA and craft beer because I want to enjoy them together and things like that. And that we could analyze what is the best assortment to increase people's customer lifetime value. So here's another case that is not about us, Thinko, but then it's another case to demonstrate demonstrate the importance of recommendation engine. So back then Netflix wasn't streaming yet; they were doing DVD, and they want companies to create a better algorithm for them to predict recommendation engine. So then they found a team. They gave out $1 million for price, and then found out there was a team who predicted better algorithm to predict movies by 10.06%. But at the end of the day, they haven't used this recommendation engine. The reason why is that it took them too long to do the 10.06 increase in accuracy. By the time Netflix already started switching to streaming, so the business change made it not worth to implement that. Further, the additional accuracy gain that they measured did not seem to justify the engineering effort needed to bring them into a production environment. While we do a lot of AI roadmaps for companies, we always emphasize time and feasibility compared to business value. Sometimes if it takes too long, like for example over there, it takes like them a year to create such an accuracy model. It might be better to just do something that improve 2 or 3%, but then you start the AI roadmap, you start building AI projects, you start the ball rolling, so you know what to do and what not to do. So this is a case that we're working in Hong Kong with a property conglomerate. So basically, they have a lot of different stores in Hong Kong. For example, they have shopping malls, They have property, apartments. They have loyalty data. They also have education stuff and everything. So one thing that they did really well is that they were able to integrate everything into a big system. And then by integrating everything into a big system, they could start doing what I meant earlier with the customer segmentation and then targeted marketing. But then the problem with this is that a lot of times they have more people online than offline. So then they were trying to see how I could use the data online to segment, to from that segment to find people offline that they could target. So that is a problem we work with, and there was a lot of ways of doing it. For example, with finding. So the main important thing for here is that from the online segments, we have to create features or attributes that really is more interpretable, that the marketing team could really interpret, so that they could use it for the offline team, and that took us a lot of time to figure out. So for example, here are some of the features that we did. There's a normal RFM features, recency, frequency, monetary features. For those who don't know, I'm sure you could just go online and see what they're about. A lot of customer segmentation, basically they're using RFM features to do. And also purchase diversity, where they purchase a lot of different things. We also do group features. For example, average spending of a certain members tier, proxy features, like the spending on education center is a proxy to them having children. Since we're talking about online websites, we also try to figure out key event features, whether, for example, they buy a wedding ring or something. If that means these people are probably at a certain space. They're probably looking to get married. Loyalty data, visits of specific information, important sites, as I mentioned. These are more manual features, because if we just do every single link on the website that they go to, there's too much. So we have to find certain important sites to put into a machine learning model to customer segmentation. Location data, payment gateway, car park usage and data, Wi-Fi usage, and social media data. So we created like more than thousands of features, and then we use these features to do customer segmentation, as well as to predict whether they would do certain events. Events as in, for example, buying a property, or let's say joining a certain class. Because of time, I'm going to skip over some of the cases and go out to the AI roadmap part that I mentioned. So this is a lot about how we usually kickstart an AI roadmap. Different companies have different ways. Usually, like when they hire us, we go in. There are a couple ways of doing it. We could first do a general consultation, trying to understand the data, the project scope, and then we quickly try to build the first prototype, and then we try to deploy the prototype. Now, this is a very simple way of doing it, but then every company's AI journey is different. Sometimes when we go in, that was what happens when the client really knows what they're doing. For example, we have this beverage company that wanted us to do demand forecast, and they say, I just want you to do demand forecast. And then it's easier for us to just go in and start building a project like that. But then every company's AI journey is different. There are some companies, they don't really know what kind of AI project to do. And so for those, we would do more about some design thinking workshops for them to understand how to do it. So usually, other than just starting right away, we could do an AI and data science workshop, or another way is that we could do hackathons. For those who don't know, hackathons are around 2 to 3 days events where a company throw out a business problem and then ask different participants to solve it in kind of a competition. So we will hire engineers, students, professionals, data scientists, UI UX experts, software engineers, and we'll throw them a question. For example, how could we predict the sales for let's say a new product, and then they would have 48 hours to try to solve it and to try to pitch their ideas and things like that. This allows a company to think of a lot of data science and AI ideas they might not have thought of. And finally, we could also do it through data visualizations, analyze the data and see if there's any interesting insights to create data projects out of it. So this is for certain companies who might not know how to start their AI initiatives. We also help AS Boston to do an AI lab before. which kind of is a combination of a hackathon and also a more managed vendor client relationship. Basically, in every 1 or 2 months, we throw out a new case study for different clients. So, for example, one day we will say, where should we? 1 month we will say, where do we open a new store, a new retail store in Taiwan, and then we'll send out a case study to 30 different companies and ask them to pitch us. And then they come back to us. They try to pitch us. They try to pitch us what kind of ideas they have on how to solve it. And then we will pay them to create prototypes so that they could show us what they could do. And then so for us, Thinkle, we help them manage the client vendor relationship. We help them to code review. We help them to see what's happening. And Watson's will provide them with data so that these vendors would show off the use case back to Watson's. And then we do that 1 time, for example, the new site selection I mentioned. Then for the next 2 months, we might do assortment planning and things like that. So I mentioned that we also do training. A lot of companies might not know how to do data science and AI, and they may have problem in thinking of ideas. So what we do is that we also do AI workshop so that they could understand them. Using design thinking, we take a lot of exercises from design thinking, ask them to first identify their target audience, and then to try to understand the pain points, and then ask them to create how might we statement. For example, how might we be able to do something, and then try to ideate AI solutions over there. So usually we do give them a lot of use cases. Just now I mentioned some of the use cases, but then we let the client know a lot of the use cases out there so that we could let them think of potential AI use cases. And over there, then finally we could ask them to ideate such AI use cases so that they could present their roadmap to us. And then we would consolidate all the ideas for the client. For example, 2 weeks ago, we were working with this big property company in Hong Kong, and then we go through this, and then they came up with a lot of ideas that they might push for this property company. So usually when we ideate, we tell them that there are no bad ideas, ask them to capture everything, quantity over quality, and go for hybrid brainstorming. And then finally, as I mentioned, with an AI roadmap, the most important thing is that we do emphasize the importance of feasibility and business value. So after they ideate and think of all these ideas, do all these exercises, we ask them to graph all the ideas on a map like this, where we say, what is the business value of your idea? Is there a change in efficiency, cost saving, revenue increase, synergy with other parts of business, compared to feasibility? A lot of times the business user, they might be very good with the business value, but might not think about the feasibility, such as the data readiness, whether the data is clean, whether the data is collected, and also how much time it would take, the cost for the engineering effort and execution. Sometimes we do bring in the ID team for the feasibility part. I guess right now, I'm just trying to read out some questions. I think I still have 5 more minutes. Yeah, I still have 5 more minutes. So let me just quickly go through my next slides, and then I'll go to Q&A. So then we also have like major challenges in AI adoption. One thing that a lot of companies we have before they could do AI roadmap, and then whenever we do AI roadmap, we do ask them, is there data problems about how silo everything is. For example, there's a property company that we worked with, another one in Hong Kong, that they have a lot of data, but then they're all siloed in different databases. So they're not able to do the targeted marketing they have because they want to consolidate everything that they have. Now, this, we always think that is an important step, that you have to consolidate all the data. Otherwise, the machine learning might not be that good. But we usually do ask them that while they're doing it, to try to do some very small AI projects, some small customer segmentation, just to generate, let's say, reports or visualization. Because it's when you do small AI projects or small data science projects that you really learn how to organize the data, and to also really show the value of the projects you have to management. Because if you just spent 3 years creating this big data lake, there might not really be any use for it, because by the time in 3 years, management might be like, okay, well then what do we do? And then if at the time you start thinking about it, it might be a little too late. So we usually say yes, you definitely build that data lake, but at the same time try to do small machine learning projects. And then also another thing that we usually do is to ask them to how to integration of AI to the current workflow. A lot of times, when you do for example, we did the demand forecast for this beverage company in Hong Kong. We could predict the forecast of the demand, but how does that integrate and how does that change what people do? For example, like could we change how the shipment of the different beverage to different companies? Is that doable? Another example that we could do is that for a retail store, for a beauty retail store, they have to change their assortment, but then could they actually do that? For example, like since there's so many retail stores, I say I want to change product A to B. Could they actually do that in a week? These are questions that you really have to ask people, because if you don't ask them, they might say yes, we could do it. But then after you build all the models, after you do everything, it turns out that they actually don't have the personnel, they don't have the processes to do it. And so it's important to start the question early, to start these questions about, hey, do you have processes to change certain things? Otherwise, we could build the best model, but then we could still not use it because the workflow is not optimized to change. Which also goes back to my point about starting small projects first, because when you start a small project, these would show. Let's say we are trying to change assortment planning, and we realize that, there's no processes to change the assortment. They change the assortment only once every 3 months. And then these problems would show, and we could think about whether we could change the processes or we have to change the AI system to cater to this. And then again, I keep repeating this point. To start small, to aim for low-hanging fruits before aiming for the big one. Use AI incrementally to prove value, collect feedback, and expand accordingly. And then afterwards, start AI strategy. And then there's also a survey that came out last month. I think it's by MIT and BCG. It says that even if an initial project doesn't yield a big payoff, the most successful companies learn from early uses of AI and adapt their business practice based on the results. By doing so, 73% they see return from their investment. So the survey basically was saying that that AI projects are really hard to do, and sometimes it really doesn't yield a big payoff. But then the most important thing is that you have to learn from the lessons, and that it's not just computers learning from human, it's also humans learning from computers. That I might have to change the workflow, or I might have to change it so that when new data comes in, how can I feed it back into the computer? And then finally, this happens a lot in Hong Kong. It's company culture. It's really trying to change people so that they embrace AI. So there are things like hackathon trainings and accelerator, so that people would start really understanding that, AI really do have value. And this is not just, and so we usually do training for both top management, which is around like 1 to 2 hours, and then we have longer sessions for people underneath, let's say middle management, and also business users, so that they could actually implement the AI strategy that the management people think of. I think I will stop here and do some Q&A, because I think I have around 5 minutes left. So I guess there are 3 questions. One is about privacy. Could personalized AI recommendation be normalized in the future as an everyday thing, even though now it feels like an invasion of privacy to some degree? So I think privacy, for myself, I used to be a privacy expert at Ernst & Young. And I think what I see is that with privacy, technically speaking, as long as we don't collect personal data, there is no infringement of a lot of ordinances, because a lot of personal data ordinances talks about personal data. So as long as you anonymize it, it's okay to use it. A lot of companies are trying to do that, and obviously there will be some infringement of our own privacy, not violating the law, but how people feel. But then this, I think, with the younger generation, they are more and more used to it. With things like TikTok, Facebook, people seems to care more about convenience than privacy. This is obviously an ongoing debate. But then I think for companies in general, how they can protect privacy is to make sure they don't really use any personal data when they do analysis. For example, if they want to hire a data science consulting firm like us, they make sure they give us anonymized data so that to protect their clients' privacy. Then the second question is, when developing AI, what kind of protection measures would you suggest, knowing that just a wrong pixel value in a picture could hurt the model or the hardware? So I think this is talking about image recognition and how deep learning, with a lot of like how sometimes changing a pixel, because of how deep learning works, they might think that the pixel is very important, and when you change the pixel, they might not be able to recognize the image. So I think this is about AI ethics and about really just be really careful about that. Like with image recognition, it might not be that obvious, but when you use AI to do some really important questions, such as there were AI who acts like a judges in the States beforehand. For those, you really should have a third party to look at it, to look at if there's any bias in the computer. With the wrong pixel thing, there are ways to see how good the AI is and to point out these problems. Sometimes it's really good to find a third party to do an audit, to think about the bias, to think about the ethics in using AI. This is also very prevalent in some insurance companies that I've been talking to. These insurance companies are using AI to determine how much to charge certain people. And those, again, it's really important to hire some outside consultants to come in to think about ethics, to think about bias, to think about privacy, to think about security. There's also a lot of AI ethics framework out there that for things like that you could use as a protection measure. There's a lot by universities and also by some communities that you could follow kind of a framework, and then could try to follow a checklist to make sure that the AI protection measures are in place. Then I have a question about my experience, which one is most memorable. I would say it's a Lenovo project, because we had to fly to Beijing to do that, and that was quite fun. And also, it's kind of our first project. Back then, we are quite a small team, so everything we have to do ourselves. The more I think about AI projects, I think sometimes it's not really about the technology and about the AI and about the algorithms, but it's about talking to your client, building trust between us, and showing that we could do the work. Obviously, showing them doing the work is very important, but also being able to understand the language, being able to relate to them as a person, understand the business value, understand their problems with the boss and what they really have to show the boss, and then really show them that the product itself might not be perfect, the machine learning solution might not be perfect, but it's good enough that everyone can use it. And then once they could persuade the boss, that's when you start refining the algorithms and making something better. So I think right now it's 11:50. So I think my session is over. So I guess, yeah. Thank you for listening. And yeah, thank you for listening, and have a good day. You can also ask everybody to. You can also come to the Ask Me Anything corner. I'll be there for a little bit.